Check out the beat while my DJ revolves it. Math. Critical numbers, critical numbers. Try this. Pause, copy, try. And the solution is coming now. This one's a little bit tricky. What would I do? For this one, when I have a constant on top, I avoid quotient rule by writing it like so. Seems quicker to do chain rule here. -1 comes down, subtract 1 from the exponent, and then times the derivative of the inside function. And what do I get? I get 2x with a minus all over x squared minus 1 all squared. Okay, f prime of x equal to 0. That's going to happen when minus 2x is 0, x equals 0. And then you have the f prime of x does not exist. When does that happen? That's when my denominator is 0. So I have x squared minus 1 must be 0. So x has to be plus or minus 1. Okay, tricky, tricky. A number c is only a critical number if it's in the domain of the original function. X equals 0 is in the domain, meaning I can take this x equals 0, plug it in here, no problem. But these are not. Plus or minus 1, these are not in the domain of the original function. So these are not critical numbers. So let's write that. Not critical numbers, since plus or minus 1, these are not in the domain. And this guy, x equals 0, is Cn is a critical number, and it's the only critical number. Okay, watch out for that. So what is plus or minus 1? Okay, they're not critical numbers. These are vertical asymptotes. Asymptotes. Okay, these are functions. These are points at which my function goes like this, or maybe like this, you know. But these are not critical numbers. Okay, watch out. Another example. Okay, pause and copy this. Give it a try if you like. Nothing new here, it's just getting used to factoring derivatives is the hard thing. So f prime of x, here the quotient rule cannot be avoided. So forgive me if I reuse the letter f. I got f here, g here. So I got g. F prime, which is just 1, minus f g prime. So g prime, the half comes down, times x squared plus 16, subtract 1 minus half, and then times the derivative of that x squared plus 16, all divided by g squared. And as usual, my numerator is a mess. I should factor whatever I can. I'm going to factor the smaller power of x squared plus 16. And what do I get? So that smaller power comes out. Now what's happening is I'm taking this and I'm dividing it by this. So again, this divided by this. What do? You subtract the exponents and you get a half minus a negative a half, giving 1. Now, continuing with my factoring, I get, well, I see something here. I see this 2 here can cancel this 2 here, so why don't I do that? And what's surviving? Looks like minus x plus 18. Okay, now in the square bracket, I'm just going to expand and collect like terms. Minus x squared minus 18x. All over x squared plus 36. And I'm also going to bring this down to the denominator, to the 1/2, and then I get, what has happened here? I'm sensing a mistake. Let's have a quick gander to see if I made a mistake anywhere. So, maybe not. So here's what I do when I think I have a mistake. I basically just double check everything carefully. So I got my f and I got my g here. So I'm just going to double check my quotient rule. So I got g. There it is. Right away, I made a mistake. So I got g f prime minus f g prime. So I put a 16 instead of a 36. And I made that mistake right here and right here. So my apologies. So go through and fix that. So my 16 becomes a 36. Mm-hmm. 16 becomes a 36, so my 16s become 36s. So I'm going to fix that. Yeah. 36. And what else? 36. Okay, you may want to pause and have a quick look at that. I think I got my problem dealt with. Okay, let's keep going. X squared cancels with x squared. I get 36 minus 18x upstairs. And downstairs, I'm going to add my exponents. This right here is an exponent 1. Exponent 1. So 1 plus a half is 3/2. And there we go. And there's my derivative in reasonably factored form. Suppose I could factor the top a bit more, but nobody's perfect, eh? Where was I? Okay, critical numbers. So f prime, what kind of f is that? F prime of x equals 0 when the numerator is 0. So looks like 2. X is 2. F prime of x does not exist. I would need the denominator to be 0, but that's never going to happen because you would have x squared plus 36 is equal to 0. Okay, the way I think of this is that I have a positive number plus a positive number. How can that be 0? It cannot. Okay, if you want to try to solve, you have a something squared equals negative. Nope, no solution. If I would usually just stop here and say, positive plus positive cannot equal 0. Okay, so this is my only Cn here. X equals 2. And, I suppose I could check it's in the domain, but yeah, it's pretty clear up here. So x equals 2 is my only critical number.